Hello and welcome to a new video that is on basic organization of computer. Okay, before starting into the topic, let me ask you a question. What is the task of a computer? Well, you people may have different answers of this question, but essentially the task of a computer is to execute programs. What I mean by that, whatever you do in computer, be it surfing internet, be it scrolling through Facebook feed, or listening a song, watching a video, or doing programming, whatever you do, you are essentially executing programs. And this program's execution is so much varied in nature. There are so many variety. They are so different. So, how a computer cope with such a variety of level of instructions and how they are executed? We will take a top level overview of this in this lecture. So, what is the task of a computer? To execute programs. Okay, fine. Now, suppose you say add. Suppose you say add a comma b. Now, this instruction add a comma b cannot be understood by a computer. Why? Because this is English language and computer doesn't know English language. It can only understand ones and zeros. So there has to be some mechanism through which these instructions, this high level instruction, has to be translated into that level of instruction what a CPU can understand. Now let's say that A is 10 and B is 20. Fine. Now this value 10 is located in A. That means it is located in a memory location which is identified by A. That what I mean to say, that if you have a memory like this, consider this as your memory. So inside memory there are many blocks, and in some block inside somewhere, let's say location 100, it is identified as A, and inside that we have the value 10. Let's say in location 200 it is identified as B, and inside that we have the value 20. Now when we say add A comma B, or when we give the computer this instruction to add A and B, we are actually giving a top level instruction, high level instructions. So a compiler will translate this instruction. Compiler job is not to find errors, but to translate this instruction into pattern of bits of ones and zeros. I don't know what would be this instruction pattern. I am taking any arbitrary bit pattern, but this arbitrary such bit patterns will represent some instructions. Now, this particular bit patterns are stored inside memory. So, suppose in a location 300, this particular bit pattern is stored. Now, when I have to add A comma B, this location has to be accessed by the CPU to actually get these bit patterns, right? So, where these ones and zeros are stored? Inside memory. Now, this memory consists of usually primary memory and secondary memory. What is a primary memory? Primary memory is RAM and ROM. Of course, I am pretty sure that at this point you have heard about RAM ROM. What is RAM? RAM is random access memory. And what is ROM? ROM is read-only memory. RAM contains instructions, the values of variables, and the recently accessed things by the computer. What is ROM? ROM is read-only memory. You cannot write it something there. So inside ROM, we only store some specific data which don't need to be changed. And usually a ROM contains the BIOS of a computer. Now, when I talk about memory, remember I am considering this RAM, not ROM. Now, what is secondary memory? Secondary memory is your hard disk, your solid state drive, your pen drive, your DVD, CD, and these things. So, secondary memory are of non-volatile in nature. They can store data, and even if you switch the power off, they can keep it stored. Means data is not lost after the power is lost. But RAM is such a memory, whenever you switch off the computer, everything inside a RAM is lost. Okay, that is very school level knowledge. You must have this as of now. Now, when let us get back to our discussion. Suppose this bit pattern is stored inside memory, inside the location 300. Now CPU, now this instruction has to be brought to the CPU, because we want to do the addition operation, and addition cannot take place inside memory. This is very simple common sense that it has to be brought to the CPU, right? So the first step is basically fetching the instruction. So what is meant by this? That the instruction is brought from main memory to the central processing unit. Well, the data that we have as a form of instruction will travel through this system bus. This system bus will carry forward that instructions, that numbers, that patterns of ones and zeros from memory to the central processing unit. Now we will talk about system bus, the three system buses that we have: address, data, and control bus. We'll talk about this later in this video. Now you have the instruction inside CPU. Now where it is inside the CPU, we will not discuss in this video right now. Just to keep it simple, very simple, this instruction is inside CPU. Now, how the CPU will decide, looking at 1010101111, what to do? Is it addition? Is it subtraction? Is it multiplication? It is division? Or anything else? So there has to be some mechanism by which CPU can understand what to do. This is called decoding. So what is meant by decoding? Decoding means to analyze these bit patterns. Suppose if an instruction start with 101, it is meant to add. Suppose an instruction start with 111, it means to multiply, and so on and so forth. So this 101, this 111 are, in technical term, they are called opcode or operational code. Opcode or operational code. So what they signifies? They signified what operation to do. Now I have taken any arbitrary value. Don't be very I am not very specific to a processor value. This is any arbitrary value. I am taking it for example. Now a CPU will decode this instruction. Now where this decoding will take place? It will take place inside this control unit or inside this CU. So control unit will decode the instructions. Now after it has decoded the instruction, after it has understood, okay, I need to add a comma b, I need to add 10 plus 20, then what to do after that? Of course you have to do addition, right? So after decoding, we usually do execution. And where this execution is done depends. If it is a arithmetic operation, for example, I have taken add a comma b, it is an arithmetic operation, right? Addition of two numbers. So inside CPU, we have a unit called ALU or arithmetic logic unit. This ALU can do arithmetic operation as well as logical operation. What are logical operations? Suppose you want to check two numbers which is greater or which is smaller. Suppose in 10 and 20, within between 10 and 20, which one is greater? You can very simply answer B, 20 is greater than A. Now how a computer will decide? It will be decided inside ALU. Inside ALU we have logic circuits that will decide whether A is bigger or B is bigger. So for as of now we are doing addition operation. So inside ALU we have some special kind of circuitry, or for addition specifically speaking we have adder circuits. Now interestingly, this adder circuit is so versatile in nature that it can add, it can multiply, it can divide, it can subtract. Yes, this adder circuit with a little modification in circuit and in wiring and with little modification in algorithm, we can do variety of tasks. So we don't need to build a multiplication circuit, or you don't need to build a subtraction circuit. All an adder circuit can, the same adder circuit can do the job. Okay, now after the execution we need to store the information, because 10 plus 20 is 30. So you have 10, we have made the addition inside so ALU, suppose ALU has generated the output 30 and it has to be stored in some location. So where it will be stored? Suppose in some location, let's say in the same location A will store this result 30. So again, what would be that? Storing the information. So CPU will again tell the memory to store this value. Maybe this information can even be stored inside CPU as well. So inside CPU we have some memory units, they are called registers. So what they do, registers are very small storage unit and they act really fast. You can't even imagine. They, suppose I can give you an example. If I have a 1 gigahertz processor, so to access something from register we don't even need one clock cycle. What is clock cycle, we will discuss it later, but for 1 gigahertz processor, even half nanosecond is enough to access a register. A half clock cycle will do the job. Anyway, so we will talk about what different kind of register we have, what are those functionality, how those registers communicate with each other, and those things. After discussing this much, let us discuss something about this IO. What is this IO? IO is input output. Even every school kid knows what are the input output devices. These are keyboard, mouse, monitor, printer. Everybody knows that, right? What is the specialty of this? What IO does? They do not execute programs. They basically communicate with the user. So a computer cannot do job with himself. We have to give instruction. We have to tell the computer do this, do that. And this communication is done through IO or input output devices. Suppose you are typing add a comma b. So this is an instruction, right? So this instruction you are feeding it into the computer through keyboard. So this is an input device. You are getting display that 10 plus 20 is equal to 30 through output device. This is monitor, suppose, or you are printing, this is also an output device. Okay, so IO basically consists of these things, and later through the codes we will see that there are many IO interfaces. What are those functionalities and those things? Now let us write one by one what is the role of ALU. So what I told you, the role of ALU is to make arithmetic and logical operation. So it is responsible for arithmetic and logical operations. Okay, Now, what is the role of control unit? As I told you that decoding takes place inside control unit. So its purpose is to decode those instructions. Decode the instructions. And after decoding, when that what to do means a computer has to be given some signals. Okay, so after decoding what to do, accordingly control unit gives some issue some control signals. So its second job is to issue control signals after decoding takes place. So issue control signals. Okay, now let us talk about the system bus in detail. Now we have three kinds of system buses, right? Address bus, data bus, and control bus. First, let me tell you why we have three kind of buses and what are actually buses. Buses are nothing but wires. They carry current. Okay, so address bus carry addresses. They are meant to carry address. Data bus is meant to carry data, and control bus is meant to carry control signals. So what address bus do? They carry the addresses. I told you now that this value of a 10 and the value of b 20 is located inside some memory. So these memory blocks will have some addresses by which we can uniquely identify them. Now these addresses has to be known to CPU, right, to access a and b. So how this address will go? This address means inside CPU this address calculation will happen, and this address after it is calculated it will be given to the address bus, and this address bus will carry the address to the memory, and memory will find the value and it will give it back through data bus. So through data bus this data, or even through data bus we can carry instructions as well. So this instruction 1001, this will be carried through data bus to the CPU. So what an address bus does, it carries the address of instruction and operands. What are the operands? A and B are the operands. So when we suppose for example, if I write A plus B, this A and B are operands, and this plus is operator. So the address of A and B will be carry forwarded through address bus. So these are the okay, fine. Now let's talk about data bus. So what data bus do? They carry data. They carry data and instructions, both. So data bus is capable of carrying data instruction. And let me tell you, this address bus is unidirectional. What is meant by unidirectional? That it can carry data in only one direction. Why? Because let's see, when an address, after calculating the address, suppose this address is given to the memory. Do we get back address from memory or do we get back value from memory? We get back data or value from memory, right? So address is always unidirectional. We don't need to have a bidirectional bus. So address bus is always unidirectional. And data bus, what about data bus? Data bus is bidirectional. They are bidirectional in nature. Why? Because suppose you have to store the value of 10 plus 20, which is 30, to a memory location. So 30 is a data, right? So how that data will be going back to memory to a new location? Through data bus. So data bus can carry the instructions, can carry the value of operands, as well it can store or it can write back to memory. And what is control bus? Control bus is what a control bus, they carry the instructions issued by control unit, right? So what is the nature of control bus? They are usually unidirectional. I'd say that they are usually unidirectional, but sometime in some situation they are even bidirectional as well. So it depends. Okay. So in this lecture, what we have learned how instruction is fetched into the CPU, how where the addition is done, where the subtraction is done, and how buses help the different components of a computer to communicate. In the next lecture, we will discuss on architecture, famous architecture proposed by mathematician von Neumann and its drawback, and how Harvard architecture rectifies those drawbacks. So have a happy learning. Goodbye.